All right, so we need to go over scientific notation. Not sure how much you've seen of this in the past. Should have seen it last year in physics, but if you've forgotten about it, that's fine. We'll go over it again. So scientific notation is a way of taking really large numbers and writing them in a smaller format, or really small numbers and writing them in a smaller format. Show what I mean in a minute. Scientific notation is often used in fields of science where they have to deal with really big or really small numbers. People studying the stars, solar systems, where the distances between planets and whatnot is really huge. Or molecular science, where you're dealing with particles, parts of atoms, things that are so small that you're using really small numbers. When I say a real small number, something like 0.00000000678. All right, so if I had a number like this, 97654200035, and in scientific notation, rather than writing this whole number, scientific notation is going to allow me to write this as a power of 10. So whenever we write scientific notation, the process is always the same, and it's really, really easy. Scientific notation is you're going to put a decimal behind whatever that first digit is. In this case, the 9. So I'm going to put 9 point, and then I don't have to bother writing the whole number. I'm only going to put the first 2 or 3 digits behind that decimal. In this case, I'm just going to put 2. 76. All right, so you're always putting a decimal behind that first digit. After that, then you're going to write times 10, and we're going to have to put an exponent here. Times 10 to some power. Well, the power is easy to establish because you're simply going to count how many digits are there behind where we put the decimal. So remember, we put the decimal here. And so how many digits are there behind the decimal? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Since there are 10 digits behind the decimal, the exponent is 10. All right. However many digits are behind the decimal you place, that is what the exponent will always be. Example, if I had 6, 4-025. If I want to write this as scientific notation, I put a decimal right here, and we'll call it 6.4. Then I'm going to write times 10. And now, since this is where I put the decimal, there are 4 digits behind where I put the decimal. So that makes the exponent 4. So this is the scientific notation of this number. All right. Now, scientific notation can be used for very large numbers, or we can use them for very small numbers. When the numbers are large, we use positive exponents. So whenever you see scientific notation written with a positive exponent, you know that that's a large number. On the other hand, if we have really small numbers, such as 0.00000000431. Now, when we write this in scientific notation, the process is still the same. I'm going to put a decimal behind the first digit that's not 0. In this case, that's going to be right there. So this is going to be 4.31. And now I have to see, in order to get the decimal from here all the way to here, how many places did I need to move it? So we need to move it like 1, 2, 3, 4, 5, 6, 7, 8, 9. We had to move it 9 places. So this is going to be times 10 to the negative 9. We use a negative exponent to denote the small numbers. All right. So whenever you see a negative exponent, you know that this number is actually really small. Positive exponents, really big. Negative exponents, really small. So if I had something like 0.000637, I'm going to get 6.37 times 10. And then I'm just going to move the decimal 1, 2, 3, 4 places. So that's negative 4. All right, so that's how you take the numbers and turn them into scientific notation. Let's take a quick look at how we take the scientific notation and turn it back into the number. So if I've got 5.08 times 10 to the 7. First off, the fact that my exponent is positive, is this representing a big number or a small number? A big number. Positive exponents always represent the big numbers. So since I know it's a big number, which way should I move the decimal so that it becomes a big number? Hopefully everyone sees that I would move the decimal this way. And this is how many spaces I have to move the decimal. So if I have 508, starting from here, if I move the decimal 7 places, it's 1, 2, and then 5 more places, so 5 zeros. And then put in, before I put my commas in, make sure everyone understood that. Just because this is a 7, it didn't mean I put 7 zeros, all right? That's not the process. If that's what you're getting out of this, pay attention again. This is how many places you move the decimal. Right now, just to get the decimal from here to the back of this number, I have to move it 2 places. Since I have to move it 7 places in total, I move it 2 places, and then I have to move it 5 more. Hence, I get 5 zeros. Put your commas in when you're finished, so that it's easy to read the number, 50,800,000. If I had 6.379 times 10 to, I don't know, 10 to the 12. Again, positive exponent. Positive exponents represent big numbers, so I'm going to move the decimal that way. So write the number first, 6379. And then after that, move the decimal 12 places. I'll need to move it 3 places just to get to the back of the number. And then after that, 9 more to complete the 12. So I'm going to get 9 zeros. Put in my commas. And there's the answer. There's the original number. Now, you might be wondering, but how do we know what those other numbers were originally? We don't. When you take scientific notation and you rewrite it as the expanded form, the original number, these digits back here get lost. So we don't know what those original digits were. We only know what the ones in the front are. Now, what if I have a negative exponent? What if I got 1.98 times 10 to the negative 5? Whenever we see a negative exponent, we should automatically think, small number. And if it's a small number, that means the decimal has to get moved this way. So I start with 198. I'm going to move over here some, give myself some space because I'm going to have to move the decimal in this direction now. So if I move the decimal 5 spaces, I move it 1 place just to get past this digit, and then I have to move it 4 more. So that's going to give me 4 zeros. And just put next to 0 on that. Another one here really quick. If I had 2.93 times 10 to the negative 8, write down the 293. And now I need to move the decimal 8 places in this direction since a negative exponent denotes a small number. So 8 places, it takes me 1 place just to get in front of the number and then 7 more to complete the 8, so that's 7 zeros. And there you go. Go ahead now in Schoology. You have a short little guide checking for understanding to make sure you understood how to do this. It's about 8 problems. Knock it out really quick. As soon as you finish with the check for understanding, go to the next video. The next video, we'll talk about how to make adjustments in our scientific notation. All right, but do the check for understanding first and then go on to the next video.